Hello, I'm Amanda Simpson. I'm going to show you how to use the bar modelling kit. Bar models are diagrams that represent the relationships between parts of a problem. And by building a physical bar model, we can help children to consolidate and secure their understanding about those relationships. Let's start by looking at activity 1, biscuits. On the front of the card, the problem is described. So we have 7 chocolate finger biscuits and 14 ginger biscuits, and the question is how many biscuits altogether. So it's describing a problem where there is a whole that we don't know yet, but we do know the 2 parts, so we can work out the whole. We're not at this stage expecting children to learn about addition and subtraction per se. What we want is for them to understand about parts and wholes and how they relate to each other. The bar model that we need to build is shown on the back of the car as a diagram. So total number of biscuits is the unknown whole, which is made up of 2 parts. The 2 parts are chocolate fingers and ginger biscuits, and we do know the value of each of these. So when we build our physical bar model using the magnetic bars, which is the next step, we need to bear in mind the relationship between these 2 numbers. Okay, so to build our physical bar model, we're going to use the magnetic board and magnetic bars from the kit. The guidance that comes with the kit describes for each activity which bars you should use, because it's important that the bars you select do actually represent the relationships between the numbers in the problem. In the case of activity 1, biscuits, the 2 parts that we know are 7 and 14. That is that one of the values is double the other. So the advice is to use bars C and D, 2 red bars, where one is twice as long as the other. The brown bar is the bar that we use to represent the whole. As you build the bar model, talk to the children in much the same way as I'm going to be talking to you. Use similar prompts and do keep repeating them. So in this problem, we know that there are 7 chocolate finger biscuits. And this is the bar that shows us the chocolate finger biscuits. We can label that 7 chocolate fingers. We also know that there are 14 ginger biscuits, and this is the bar that represents our ginger biscuits. 14. What we're trying to find out is how many biscuits there are all together. And this brown bar always represents the whole. We don't know at the moment how many biscuits there are altogether, so we use a question mark to label that one. But we can see that by putting these 2 values together, that is how we're going to work out what the value of the whole is. I would suggest that as you're working with very young children who are just starting to learn about these concepts, that it's well worth it at this stage to recreate these 2 bars using multi-link. Make a stick of 7 cubes and a stick of 14 cubes. Stick them together and ask the children to count how many altogether with you. Of course, you'll get to 21 in the end, and that's when we can talk about 21 being the answer to this problem. If there are 7 biscuits and 14 biscuits, how many are there altogether? And that's the point at which we can remove our question mark, make sure the children are confident that they have actually found the answer to the question, and that is 21. Activities in this set are designed to consolidate understanding about parts and wholes. This is the basis of much of the calculating that children will ever need to do. And indeed, as they get older, bar models will help them to represent and understand quite complex concepts and relationships. Let's look at activity 2, Grandad's Vegetable Garden. In Grandad's Vegetable Garden, there are 27 rows of vegetables. There are 18 rows of cabbages and the rest are carrots. Again, we see we have a whole, that's the total number of rows of vegetables, and we have two parts, rows of cabbages, rows of carrots. The difference with this problem compared to activity 1 is that the unknown value is not the whole, it's one of the parts. So after going through the question a couple of times with the children, start to think about the bar model itself. What are the bars? Our whole rows of vegetables we actually know is 27. And this is made up of two parts, rows of cabbages, rows of carrots. We know how many rows of cabbages there are. The part we are trying to find this time is how many rows of carrots. So we can start to build our physical model. We can start with the whole, the brown bar, which we know is 27 rows of vegetables. The part that we do know the value of is represented by red D again, as advised in the guidance. So this is one part that makes up our whole. This is the cabbages. This is 18 rows of cabbages. The part we don't know the value of is the part that fits in here. We can use red C to represent that part. Fits exactly together to be the same as the whole. This is the question mark this time, the unknown value. This is the rows of carrots. This is where you will turn to your multi-link again. Build a long stick of 27 multi-link, counting them up together with the pupils, and agree that by removing 18, which represents the rows of cabbages, what you will have left is something that shows you how many rows of carrots. And you can count that stick together. And of course you should agree that the number of rows of carrots is actually, of course, 9. But at that point, it's not all over. You should go back and repeat those conversations about the fact that this part and that part together make up the whole, and 18 and 9 together make a whole, which is 27.